the final lesson for section 8.7 is going to look at how we can find complex roots to quadratic form equations. Just a quick review so that we remember what a complex number is. Let's first start off with what an imaginary number is. And to do that, we also need to talk about the imaginary unit. So the imaginary unit, if you recall from Tech Math 2, is the square root of -1. And we said before that this doesn't produce an output in the real numbers, but it does in what's called the imaginary or complex numbers. And it produces what is called the imaginary unit I. Now, most books use the letter I. This book, because it was written by electronic engineers, uses the letter J as well. So sometimes you'll see either one of these interchangeably. For the notes, I've used J here because that's what our book uses. So, an imaginary number is any number of the form bi or bj. It's just a real number, so where b is a real number and I is the imaginary unit. So some examples would be 3i, -2i, -I. Those would all be examples of imaginary numbers. Now when we add another term in there, when we add a real number to an imaginary number, we get what's called a complex number. So a complex number is any number of the form a plus bi, where a and b are real numbers. So some examples of this might be 2 plus I, 3 minus 2i, 5 minus I. Those are all examples of complex numbers where we've got a real part and an imaginary part. So the rectangular form of the complex number is just that form that we saw, a plus bi, where, and I just use this language up above, a is called the real part and bi is the imaginary part. So again, that's just a quick review of complex numbers. One other thing to keep in mind is once in a while, for these examples, you won't really need it as much. Sometimes it's helpful to remember the powers of I. So if you recall, I squared is -1 because you would square that square root of -1. I cubed is -I because you get I squared times I. And I to the 4th is 1. And this cycles every 4 units. Another quick thing to recall is the quadratic equation. Sometimes we use this to solve equations in quadratic form. Again, this is x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And it's very important that we make sure that the whole thing is divided by. And again, this is for equations in the form that we defined at the beginning of this lesson in the previous video as being ax squared plus bx plus c. And so that's where the a, b, and c from this formula are coming from. Now, if the discriminant or the number under the radical is positive or 0, then we end up with real roots. That's what you've dealt with so far. If instead, however, the discriminant or the number under the radical is less than 0, then we end up with a complex root. Now, it's not always imperative that we use this. Sometimes we can solve equations like this first example by just moving the 12 to the other side and taking the square root of both sides. So in this case, we would say, okay, I'm going to subtract 12 from both sides. And when I do that, I end up with x squared is equal to -12. And then when I go through and solve for x and take the square root of both sides, I need to be careful that I take plus or minus, because I need to find both roots that are coming from that x squared. So this tells me that I have x is equal to plus or minus the square root of negative 12. Now we don't want to leave it as negative 12. We want to simplify that radical. So we can go back to our previous lessons on simplifying radicals. And we also know that this negative inside is going to come out and become I. So we're going to have plus or minus. If we rewrite this inside, we see that we've got a negative 1 times, if we see the biggest perfect square that divides evenly into 12, would be 4, and then we would be left with a 3. So if you take the square root of each of those, you end up with an I, a 2, and the square root of 3 is left over. And just for convention's sake, we usually write this as 2I root 3. We write the real part, then the imaginary part, and then the radical. A few more examples here. In this next one, we do need to use the quadratic formula. It's not going to factor. We can't just move the 5 to the other side. The only reason we could do that in the previous problem was because we had a squared and a constant. We didn't have that middle x term. Anytime we have the middle x term, we need to go to the quadratic formula if it does not factor. So in this case, our a is 5, our b is negative 2, and our c is also 5. So if we plug this in, one thing to remember is that you're always going to have x is equal to, and we're just going to plug in that we see here. So we've got negative 2 plus or minus the square root of negative 2 minus 4, a was 5, c was 5. All divided by, make sure you draw that division symbol all the way underneath, 2 times a, which is 5. Okay, so now when we simplify, we've got negative 2, which would just be 2, plus or minus the square root of negative 2 squared, which would be 4, minus 4 times 5 is 100. All over 2 times 5 is 10. We keep simplifying. We can't distribute the exponent here because we have that subtraction. We can't distribute that radical because we have that subtraction between the 4 and 100. So we have 2 plus or minus the square root of negative 96 all over 10. We can keep simplifying because we've got a negative inside the radical, and 96 contains a perfect square. Take a second to make sure that you see the perfect square that divides evenly into 96. You should see that this ends up being negative 1 times 16 times 6 over 10. A few more steps to simplify. We've got 2 plus or minus, if we have this negative 1, which is going to give us I, and the square root of 16 is going to give us 4. So 4i square root of 6, all divided by 10. Now there's one more thing we can do to simplify, and that is the fact that our 2, our 4, and our 10 all have a factor of 2 involved. So we can't take it out of the radical, but we can take it out of the real parts outside. So if we do that, we can factor a 2 out of the top, and we would be left with 1 plus or minus 2i root 6. Again, we can't factor anything out of the radical. There's an exponent there, divided by 10. And then this 2 divided by 10 would leave us with a 1/5. So our final answer would be 1 plus or minus 2i root 6 all over 5. And that's how you want to leave your answer, just like that. It is possible to find decimal approximations, but it is not necessary. Example 18, we have a cubic. And to factor a cubic, if you remember from chapter 5, we're going to use that SOAP formula. So we're going to take the cube root of x and the cube root of 1, and then we're going to take x and square it. We're going to multiply them together to get 1x, and then we're going to square 1. And then we're going to look at the signs. We've got the same is positive, opposite is negative, and the last one is always positive. This is still equal to 0, and again, to use the quadratic formula, we have to have the equation set equal to 0. So this first part here is going to let us know if we set that equal. X plus 1 is equal to 0 would tell us that we have an x is equal to -1. And for this second piece here, we need to use the quadratic formula. So I want you to pause the video at this point and use the quadratic formula to find the other two roots for this equation. So using the quadratic equation, this one doesn't have a whole lot of simplification involved. You just end up with 1 plus or minus I root 3 all over 2, and there's nothing else you can do to simplify this one. So this is 2 of our answers because we got plus and minus. That's 2 answers there. And then we've got x is equal to -1 is our real answer. So for a cubic equation, we either end up with 3 real roots or 1 real and 2 complex roots. And you'll talk more about this in Tech Math 4. So our last 2 examples here. Take a second here, see if you can factor x to the 4th minus 81. Keep in mind that it is in quadratic form. You've got x to an even power. So you should see that this factors to be x squared minus 9, x squared plus 9. And then again, anytime we've got a squared function, we need to see if it'll factor a little bit further. In the case of the x squared minus 9, this will factor to be x plus 3, x minus 3. However, the x squared plus 9 is not factorable in the real numbers. That's going to give us 2 imaginary roots. And here we know that this is going to give us x is equal to -3. Our second term, this is going to be x is equal to +3. And I'm going to do this part over here. If we have x squared plus 9 is equal to 0, then yes, we can plug this into the quadratic formula, but it's a little bit of overkill. We can do like we did in that first example, subtract the 9 over, so we have x squared is equal to -9, and then take the plus or minus square root of -9. So we end up with x is equal to plus or minus 3i, because the square root of 9 is 3, the square root of -9 is 3i. And so we get our 2 complex answers here and our 2 real roots here. And since this is a 4th order or 4th degree polynomial, we should have 4 answers. We got -3, +3, -3i, and +3i. For this last example, I want you to pause the video and see if you can factor appropriately, and then if necessary, use the quadratic formula or solve like we did with the x squared plus 9. So for this one, first you would factor out a 2x squared, and that would leave you with a cubic equation x cubed plus 64, which you could then factor to be x plus 4, x squared minus 4x plus 16. We know that the 2x squared is going to give us a value of x equals 0 if you set it equal to 0. The x plus 4 is going to give us x is equal to -4, and then that third part is going to give us something that we need to use the quadratic formula for. So when you go through all of the quadratic formula, you should end up with a final answer of 2 plus or minus 2i root 3. And these are your actual 5 answers, because this x equals 0 here is a repeated root. Because it was squared, it actually happens twice. So if you want to, you could write it down twice. So we've got 5 root 0, 0, -4, and 2 plus or minus, so there's our 2 roots, 2i root 3. So this concludes the lesson for 8.7. Go online and complete the homework for this section, and then complete the quiz for Chapter 8.